Hello viewers, this is Dr. Mercy Anthony, Head Department of Statistics from St. Joseph's College of Arts and Science, Cuddalore. I hope you will find this video informative, and by the end of this video, you'll be able to understand the concepts of test of significance, population, sample, steps for hypothesis testing, and problems in test for population mean. So first, let us understand what test of significance are. So test of significance are the methods of reaching a conclusion to reject or support the claims based on sample data. The test of significance enables us to decide on the basis of the sample results if the deviation between the observed sample statistic and the hypothetical parameter value, or the deviation between two independent sample statistics, is significant or might be attributed to chance or the fluctuations of sampling. Next, we'll see what population and sample means. A population is any infinite collection of elements that we want to draw conclusions about. It consists of all possible data values and items within the field of study. So, a population means it is a whole value. Next, we'll see what sample means. A sample is a subset of larger population which represents the whole population. So, for example, if I take students of a college, that becomes the example for a population. And next, if I say that students of a class from that college, that is the example for sample. So next we'll see how we can form the population, and with the help of population, how we can go for sampling, then the testing, and finally we can go for the inference of that. So here, if we want to know about the population, so which is represented by mu as the parameter, a random selection is done where from the population we are taking some values, which is also known as sample, and that is further known as x bar or the sample mean, which is used for the inference. So lastly, in the further video, we'll see how we'll go step by step by using the hypothesis, and we draw the conclusion by that. So before that, while going for the hypothesis, we'll see what small sample and large sample means. What small sample means is when the n value, that is the number of observation, when it is less than or equal to 30, that comes under small sample. And when the value is exceeding 30, that becomes large sample. So next we'll see what are the different steps for hypothesis testing. So the first one is to formulate H0 and H1. Here, H0 means the null hypothesis and H1 is denoted for alternative hypothesis. So the first step in hypothesis testing is we have to set up the hypothesis. First one will be null hypothesis, and the opposite of null hypothesis will be alternative hypothesis. So in null hypothesis, the value should be of no difference. As the name itself says, it is null hypothesis. So there should be no difference in null hypothesis. And the opposite of null hypothesis is alternative hypothesis. So it means that there should be or there can be any difference in that. So the next step will be you have to select an appropriate test. So here the formula is applied. So the next step will be the choosing level of significance. Here we can select either 5% or 1%, or based on your research, we can go for level of significance. After we have chosen the level of significance, we'll compare with the level of significance, the calculated value. And then we'll decide whether we'll reject or we'll accept the null hypothesis. So after these steps, we'll finally come to the conclusion. So if our table value, when it is compared with the calculated value, if our calculated value is less than the table value, we'll accept the null hypothesis. Otherwise, we'll reject the null hypothesis. So as I told you earlier, we'll always go for 5% or 1%. When it comes for 5%, it means that 5 is divided by 100, which gives you the answer 0.05. So when the problem is, when it comes to 0.05, the problem becomes of one tail. And when the problem is two tail, so that value 0.05 will be divided by 2, which will indicate the value as two tail. So this is all regarding 5%. When it comes to 1%, so 1% means that 1 will be divided by 100, which is 0.01. So that is for one tail. And when it comes to two tail, so that the same value 0.01 will be divided by 2, which will give you the answer 0.005, which will be applicable for two tail test. So next we'll see one problem regarding test for population mean. So the problem goes like this. A random sample of 10 boys had the following IQs. So the values are 70, 120, 110, 101, 88, 83, 95, 98, 107 and 100. So the question here is, do these data support the assumption of a population mean IQ of 100? So now here I have marked the hypothesis as the population mean IQ is 100. That will be your hypothesis. So before going for the hypothesis, what you have to see is check what is the n value. So here if you count and see, or in the problem itself, it's given like 10 boys. So your n value becomes 10 here. So which is less than 30. So that problem becomes a small sample. So that is the first step. Next is for null hypothesis. As I told you earlier, that the null hypothesis should be of no difference. So your null hypothesis here is the population mean IQ is 100. That is, it's not such that mu is equal to 100. So here mu means population mean. And next is alternative hypothesis. So the opposite of null hypothesis will be alternative hypothesis. So our null hypothesis goes like the population mean IQ is 100. So opposite of that will be the population mean IQ is not 100. So once our problem is not 100, so what we go for is, the problem becomes of two-tailed. So next step is applying the formula. So which goes like test statistics under null hypothesis. So this is the formula. X bar minus mu divided by S by square root of n minus 1, which follows T of n minus 1 degrees of freedom. So here what we have to do is we have to find out X bar value. So X bar, since this is raw data, what we can do is just we have to add up all the values. So our table will be, we have to find X and X square. So the total value of X will be 972 and the X square value is 96,312. So what we did is we are squaring up the values. For example, 70 square is 4,900. So likewise, we'll square up all the values and find the total value. Now, after we found out all the total values of X and X square, we'll just substitute in the formula. So X bar here becomes X summation X by n. So 972 is divided by 10 because our n value was 10, which gives the final answer as 97.2. So this is our X bar. Next, we have to find out S value. So it is nothing but the standard deviation formula. So root of summation X square divided by n minus summation X by n the whole square. So once we substitute in that formula, we are getting the answer as 13.54. And next we'll substitute in the modulus T formula. So X bar minus mu divided by S by root of n minus 1. So what we found out was X bar was 97.2. And in the formula, the problem, the mu value was 100. So 97.2 minus 100 divided by 13.54 divided by square root of 10 minus 1. If we calculate all these values, we'll get the final answer as 0.62. So this 0.62 is the calculated value. So the next step will be table value. So what we have to do is we have to go for table value. So the table value can be obtained from T table, students T table for n minus 1 degrees. So that is 10 minus 1, 9 degrees of freedom. Here I have taken the level of significance as 5. So 5% level of significance, the table value is 2.262. So our calculated value is 0.62 and the table value is 2.262. So now we have to come to the conclusion. So our inference goes like this. Since the calculated value 0.62 is less than the table value 2.262, thus we accept our null hypothesis. So that is the population mean IQ is 100. So with this problem gets over. Next, we'll go for the second problem. Here the problem is the height of 10 students in a school are found to be 70, 67, 62, 68, 61, 68, 70, 64, 64 and 66 inches. Is it reasonable to believe that the average height is greater than 64 inches? So here in the problem, it is already given as greater than. So what we do is, as we saw in the last slide, our first step, we have to decide whether it is small sample or large sample. So now here again the value is 10. So it becomes small sample. So n is equal to 10, which is less than 30. Then we have to set up the null hypothesis. So our null hypothesis here is the average height is 64 inches. That is, H naught says that mu is equal to 64. So the opposite of null hypothesis is alternative hypothesis. So we can write it as the average height is not equal to 64 inches. We can write that. But here in the problem, it's given that we have to check whether the average height is greater than 64 inches. Thus, what we are writing in the alternative hypothesis is the average height is greater than 64 inches. So that is H1 such that mu greater than 64. So once the value is greater than 64, the problem becomes one tail. And then what we do is we'll apply the formula. So that will come under test statistics. So our test statistics under null hypothesis, modulus T is equal to x bar minus mu divided by s by root of n minus 1. So what we do is we have to write up all the x values, find out the total value. So here our x total value gives the answer as 660. Then we have to find out x square value. So that total comes under 43,650. Then what we have to do is we have to find out x bar value. So x bar formula is summation x by n. So summation x value we found out as 660. So 660 is divided by 10. So thus we get the answer as 66. Next we find out s value. So s formula is root of summation x square by n minus summation x by n the whole square. So once we substitute the values here, we get the final answer as 3. Then the next value, what we do is we'll substitute in the formula as modulus T is equal to x bar minus mu divided by s by root of n minus 1. So here x bar is 66 minus mu value was 64 divided by s value is 3 divided by root of 10 minus 1. So once we calculate all these values, we'll get the final answer as 2. That is our calculated value. So the next step will be going for the table value. So the table value can be obtained from T table for n minus 1, which is 10 minus 1, 9 degrees of freedom at 5% level of significance. Here our table value is 1.833. So finally, we will conclude with the inference. So the inference goes like, since the calculated value 2 is greater than the table value 1.833. Thus, we reject our null hypothesis. That is, the average height is greater than 64 inches. So, thank you for your patient listening. Hope you understood the concepts